Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw something interesting, a case where R squared went up while adjusted R squared went down. And we said that disagreement was a signal. Today's question is, how do we formally test whether variables matter together? That question leads us to the F-test, which is another element that shows in your right-hand block of information in your regression output on top of the coefficients table. The F-test answers a very specific question, and that is, do a group of regressors jointly explain variation in Y? This is different from a t-test. A t-test, remember, was asking you, does this coefficient matter? An F-test is now asking you, do they jointly matter? In a typical regression, the F-test will also have its own null hypothesis and alternative hypothesis. So the way that we can write the null hypothesis is either by writing words, so all coefficients are 0, or you can write mathematically beta 1 equals to beta 2. Well, this might be a little bit, but beta 1 equal to 0 and beta 2 equals to 0 and beta 3 equals to 0 and so on, like as many betas as you need. While your alternative hypothesis usually is just written in words, so you don't need to come up with a mathematical way to write the alternative hypothesis. It's at least one of them is not 0. And that comes directly from the way that the math is written. So in here, I'm saying beta 1 is 0 and beta 2 is 0 and beta 3 is 0. So that end is adding conditions one on top of the other. And for the alternative, I just need one of these conditions to be false so that I can reject it. So under the null hypothesis, what would happen is that the model does no better than just predicting the mean of the Y. And this ties directly back to the R square. So you might think, well, why not just look at the t-test? And the thing is, there's an issue. Variables can be insignificant individually, yet they can be very important jointly with other variables, especially in cases where regressors are correlated with each other. So what the F-test does is that it captures collective explanatory power. Conceptually, the F-test compares how much variation the model explains to how much variation is left unexplained. But keep in mind, it does not compare raw variation. So let me just write this. F-test does not compare raw variation. It can compare explained variation per regressor compared to unexplained variation per degree of freedom. Okay? Let's talk about some misconceptions in terms of like the values of the F statistic. A large F statistic means that the model explains a lot of variation relative to the noise left in the residuals. In that case, it means that you shouldn't really expect to see the coefficients being insignificant or zero, okay? A small f statistic conversely would mean that, well, the model very likely will not outperform the mean by much. Again, in Stata and R, the f statistic appears like, at least in Stata, in the top right block of the regression output, while the f statistic will appear altogether with the R square and adjusted R square. And again, this placement is sort of intentional because the f-test is about the model as a whole, not the individual coefficients. And as we learned in the previous videos, R square and adjusted R square were also measures of model fit. So that's why usually they are all grouped together. Now, how does this all connect to all of the other elements that we saw of the regression output so far, meaning like the total sum of squares, explained sum of squares, R square or adjusted R square? And the idea is that we haven't really introduced anything new with the f-test. We're just making that question sharper and sharper. Because now the f-test is checking whether the regressors taken together explain enough variation to beat that very simple base mark or benchmark model that I told you, where you would have to use only the mean only model. In the next video, we'll write down the first formula for the f-test using the sum of squares so that you can connect all of the information together. And until then, stay tuned, and I'll see you in the next video.